What's up guys, this is LeetCode 687, longest Univalue path. So given a binary tree, find the length of the longest path where each node in the path has the same value. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. So example 1, we have here a balanced binary tree. Yes, which we have three number 5s in the same path and two edges here between three vertices. So the longest Univalue path here is 2 because we have two edges in a path with 3 equals vertices. Example 2, we have again a balanced binary tree, and here the longest Univalue path, different from the example above, we do not start from the root node. We start here and we have a path from both sides. We have a path going to the left and a path going to the right. So this subtree here has the longest Univalue path with two edges in a path with 3 vertices. Okay, yes. So a binary tree problem, we have to know how to iterate through a tree. I would recommend it if you do not know even one way to iterate through a tree, to search on the internet. There are a lot of links and videos explain how to do that. And here the solution will be using an approach called post-order traversion, which we will have to go to the leaf node of the tree and start our computation in another approach called bottom-up. So we will start here and going up through the nodes. So when we get here, we will start to compare if the left and the right child is equals to the current node. If it is, we will sum to a probably global variable because we need a variable that we can change its value when we are in a computation to the left side or in a computation to the right side, and we need this variable to be yes, we have to change it from both sides. So we need it to be global or a reference parameter. Yes, I think that would solve. And if the current node is not equals to the left node or the right node, we can just set the current count variable to 0, because yes, we need to reset the count of the current path. Yes, I think that's it. Let's try to write some code and see how this works. I will start by creating a variable here outside this function. So it will be our max path, and we'll set to 0. We will also create another function because we will solve this problem using recursion. I will create a function called LUP, longest Univalue path. And the only parameter here will be the current node, which is root. And after that, we can return the max path we declared above. So this function can be a private function, which will return an int, and we will use this return just within this function. We will not return to the caller. So the LUP, which will get the 3-node root. And here we can start by checking our base case of this recursion, which is if root is null, we can just return 0. And this recursion will be a, let me see, yes, a head recursion, which means that we will start to call the recursive function before we start to check if the node is equals to the left or the right child. Okay, so here we will declare a left variable which will get the count of the longest path to the left side of this tree. So we will get the loop root.left, and we'll do the same for the right side. Okay, so after we finish this iteration, we will get to somewhere here on the leaf nodes, and we will need to start checking if the current node is equals to the left or the right node. We'll do for both. So let me see, how can we do this? We can check if left is not null, and if left.vol is equals to left.left.vol. If it is equals, we can increment left. Otherwise, we have to set left to 0 because we need to reset the count of left because we find the end of this path. We have to do the same for the left side. And we just need to change here all the lefts to right. So right.vol is equals to left.vol. Yeah, I don't think this is right. I think this here we need to check actually the root.vol, and here is the root.vol is equals to left.vol, not left.left, and right.vol, not right.right.vol. Okay, so here right, and here also right. Okay, so now we have all the information we need to choose if we want to continue use this variable here as the max path, or we want to change the count of the max path by setting the max path variable to left or to right. Okay, we can do this by getting max path is equals to math.max path, or the sum of left plus right. And after that, we can just return the max of left or right. And I think if we do not have any typo here, this is the solution. Let's check running the code. Have an error here, so line 30, int does not contain definition for vol. Oh, okay, so here we have a typo, is root.left, and here is root.left, and here the same for right is different. Root.right is different from null. Root.vol is equals to root.right.vol. Okay, that's it. And here we have we we know that root is not null because we already checked it here. So let's try to run the code again. Okay, so let's try to hit submit. Yeah, that's it. So the time complexity for this solution is, let me see, yes, it's big O of n, where n is the number of nodes in this tree. And the memory complexity here for an average case, not an average case, but if a tree is balanced, it will be big O of h, where h is the height of the tree. And in the worst case, where this tree is not balanced, the memory complexity will be big O of n, where n is the number of nodes in this tree. And memory here will be used for stack allocation because we are using recursion. Yeah, that's it. Thanks for watching.